So as we prepare to test and implement first, of course, our new functions, which are conversion to uppercase, to lowercase, to uppercase, and trimming the spaces in front and in the end, let's also add spaces in front of the string. So how could we do this? So it's just something similar to what we do with concatenate. I'm still using concatenate. This time, this concatenate, I want to, like, if I want to add spaces in front of the string, like this, right, I need to construct a temporary string. So this will construct a temporary string with just spaces. Then immediately on using this temporary object, concatenate it with hello, right? Just concatenate it with hello. So this, of course, will construct the third or the second rather temporary object, and that temporary object should contain everything we're looking for, like with spaces added in front and in the end. So let's test this. It should work fine after we took care of the copy construction and assignment, the new version of the assignment operator. Let's find out how this looks like. So now we have, so this works fine, and we have an output of all of these little experiments that we tried, and now we get the string with some leading and trailing spaces that we can test with our trim function. Okay, so what could be the implementation of new functions, which are located right here? So these are the three functions that I'd like to work on, to lowercase, to uppercase, and trimming the string, which means removing spaces. So to save some time, I typed these functions already, and I'm just going to copy and paste them into our implementation file, string.cpp, somewhere right before the overloaded operators. So generally speaking, we're following the same order of function implementations as they were declared in the header file. So right here, right in the middle of this file, so let's take a walk through this implementation and quickly take a look at lowercase, for example. So the order, the objective here, is to generate brand new string, which is a lowercase version of the string that we currently have. And it's a constant function because it returns back a brand new string, so it doesn't update the current one. So we know for sure that the new version of the string is going to be different. So therefore, we immediately begin to generate a raw copy of the string that we currently have. So we basically say, okay, we have our string view, which already knows what the length of it is, adding 1 for 0 terminating character, and allocating some raw characters in dynamic memory by using the new operator. So we create this local variable, local pointer to characters, and we allocate this. So then we make a copy of what we already have. String view data returns back the actual, the pointer to C-style string, 0 terminated string. So we copy it into our new dynamic memory, okay? And then this is an example of standard library transform algorithm that essentially takes, it's asking us to provide the location of our targeted container, which in our case is just block row of characters, and from there to the length of this block of characters. So we say from this pointer to the length of these characters. We're going to extract characters from that exact location, starting at that location, and we will be passing the to lowercase function as the manipulator or transformer function to use by the transform algorithm. And once transformation is complete, so everything is converted now to lowercase characters, we're going to manufacture this brand new string that we have to return, and we say that both string view should be using this newly allocated array of characters, a dynamically allocated block of memory, and of course that the string will own dynamic memory. So remember, this specific constructor that we added to our design is to be able to accept the string, but also remember it as this dynamic memory pointer. Okay, so let's draw a little diagram of everything that we've just discussed. So once again, we have our current string. This is a member function of the string object. So right now we have our object somewhere in memory, right? So it stays here in memory, and we have our object, and it has two data members, the string view right here and this pointer. Okay, so what we do is we allocate brand new block of characters. So string view of course points to some string that it's using as its base to manipulate constant characters, and we create right here an exact copy of this block, right? Because we're asking string view, what is the size of this, right? What is the size of this? What's your length? +1 to accommodate 0 terminating character. And then, so we allocate the same block of characters. It just contains garbage value at this point. But then we copy everything from here. Now you access this through the data member function in string view, and everything that this thing contains will be copied to this place. Okay, so we just move all content from here to here. Okay, so this is now ready to go, and then we call this transform. Now notice that PSTR points to the beginning here. PSTR plus string view length will be creating a pointer which will be pointing to the end of this, like this. And then we say that let's start from the beginning over here. So we're pointing that the operations should begin right here, and we convert everything to uppercase. So now every character in this block of memory will be converted to uppercase in this range from here to here. And once we're done, we just simply say that once we have this block, a brand new block of memory allocated dynamically, let's construct the new string which will now capture this thing and hold on to it. Okay, so we manufacture this string and we return the string from this to uppercase function. Okay, so this is how it works. This is what it does with memory. So the trick is to make sure that we manufacture brand new set of characters, dynamically allocate them, and then it's safe for us to do the transformation. So we transform everything by saying that we want to transform everything to uppercase, and then we manufacture brand new string and say you own this memory, right? So because we have these design rules that if this is set, this string owns dynamic memory, and as necessary it will be able to deallocate it, and so that should be the idea behind this implementation. Of course, to lowercase and to uppercase are very similar. The only difference between these two is to lowercase and to uppercase that we use right here, right? So the two are absolutely similar. Both use transform, both use dynamic memory allocation, both return brand new copy of the string, and this constructor that we already discussed is the one that is capable of accepting the value for dynamic memory for us to hold. And the trim function that we also added right here, the trim function does the following. Okay, so once again, it needs to create a temporary object, but what trim does, it relies on the functionality of substring. Substring member function that we have, also returning brand new object. And we have the version of substring that takes a range from and to. This is how things are done in Java, because we're trying to generate an interface, this public interface of all the functions that match exactly the way you would code it in Java. So what we do is that we just need to find where is the beginning of the string that does not have white spaces, right? So trim is to be able to trim the white spaces. So let's see. So we have again this string view, okay, and the string view, of course, holds pointer to the string on top of which it builds its functionality. And this is very useful function that is available in strings and string view. So remember, string view is exactly the same as string, only it's trying to behave like a read-only string. So it's like immutable string, the string that cannot be used to modify the string, and that's why we chose it to match the Java string, because Java string uses the same philosophy. Java strings are read-only. Okay, so find first off, so we're looking for space. Okay, so this is like little space character right here, new line, carriage return, and tab. So these are white space characters widely recognized. So we're looking for something first not of that. So we have some kind of block of characters that the string view holds, and these characters in the middle, supposedly, right? So these characters are not white string characters. Okay. And this find first not of will return the position, right? The position of the character which does not match any of these characters. So non-white space. So therefore, we're generating this position. On the other hand, we are doing on the other side, we're using string view to give us last position of a character which is not any one of these, right? So the same white space character. So of course this tool should be pointing to the last character like this, and we then just pass it to our string, our substring function, then which will manufacture brand new string which will only use this fragment of the original string. So that's how the trim function is implemented. So let's just very quickly try testing this. And so these are our new functions. One only thing that I think we need to add here is the algorithm header, right? Because we just use transform algorithm. Okay, so algorithm header will provide access to all algorithms available in C++ standard library. And we need to put this to test. So I think what we're going to do is, again, we'll just do it with hello example like this. So the interface to these new functions. Okay, so we're using, let's start with the lowercase version. So we just, actually let's start with the trim, right? So we can trim this string, and trim of course does not require any parameters, and we're going to display the result. and then I'll copy and paste this result, and let's convert everything to lowercase first, and then we convert everything to uppercase. Right, so we just building this is our client example that can just do all these things with strings, and the behavior is very, very similar to Java string. So let's save it, build, and see what comes out. We run this program. Oh, I just got a problem right here. So let's find out what's not working.